Good morning and blessed day, ma'am. I will report the given chapter 7 to 10. Chapter 7. Statistical intervals. Confidence intervals for for n greater than 30. Ito po yung formula na gagamitin natin para sa sample size. Use the z-table for the standard normal distribution for n less than 30. Use the t-table with df equals n minus 1. So, this is the table, ma'am. Example, descriptive statistics on variables measured in a sample of n equals 3,539 participants attending the 7 examination of the offspring in the Framingham Heart Study or shown below. Characteristics. Systolic blood pressure N 3,524, sample mean 127.35, standard deviation 19.0. Diagnostic blood pressure N 3,532, sample mean 74.0, standard deviation 9.9. Total serum cholesterol N 3,310, sample mean 200.3, standard deviation 36.8. Weight N 3,506, sample mean 174.4, standard deviation 38.7. Height N 3,326, sample mean 65.957, standard deviation 3.749. Body mass index N 3,326 or sample mean 28.15, standard deviation 5.32. So, lilipat naman po tayo sa next na slide. Because the sample is large, we can generate a 95% confidence interval for systolic blood pressure using the following formula. Ito po yung formula na nakikita naman sa screen, ma'am. So, the Z value for 95% confidence is Z equals 1.96. Substituting the sample statistics and the Z value for 95% confidence, we have 95% confidence interval equals to 127.3 plus 1.96 or 19.0 is the root of 3,534. So, the confidence interval is 126.7 or 127.9. So, upon estimate for the true mean systolic blood pressure in the population is 127.3, and we are 95% confidence that the true mean is between 126.7 and 127.9. Substituting the sample statistic and the t-value for 95% confidence, we have the following expression. 121.2 plus 2.262, 11.2 1 the root of 10 equals 121.2 plus 7.94 equals 113.3 or 129.1. Based in the sample of size n equals 10, our best estimate of the true mean systolic blood pressure in the population is 1.21.2. Based on this sample, we are 95% confident that the true systolic blood pressure in the population is between 113.3 and 129.1. Note that the margin of error is larger here, primarily due to the small sample size. Lipat naman sa letter B. Confidence intervals multiple samples. There are many situations where it is of interest to compare two groups with respect to their mean scores on a continuous outcome. For example, we might be interested in comparing mean systolic blood pressure in men and women, or perhaps compare body mass index BMI in smokers and non-smokers. Both of these situations involve comparison between two independent groups, meaning that there are different people in the group being. We could begin by computing the sample sizes n and n means x1 and x2 and standard deviation s and s in each sample. In the two independent sample application with a continuous outcome, the parameter of interest is the difference in population means negative mu 1 negative mu 2. The point estimate for the difference in population means is the difference in sample means. So makikita dyan po yung x1 at x2. The confidence interval will be computed using either the z or t distribution for the selected confidence level and the standard error of the point estimate. The use of z or t again depends on whether the sample size are large, n greater than 30 and n greater than 30, or small. The standard error of the point estimate will incorporate the variability in the outcome of interest in each of the comparison groups. If we assume equal variance between groups, we can pull the information of variability sample variance to generate an estimate of the population variability. Therefore, the standard error SE of the difference in sample means is the pooled estimate of the common standard deviation, SP, assuming that the variance in the population are similar. Compute as T the weighted average of the standard deviation in the sample. So, dyan ma'am, makikita po dyan yung sample ng o yung gagamitin para sa o yung magagamit para sa pag-compute ng formula o following na binigay. Chapter 9. Statistical interference of two sample. The null hypothesis is nu1 less nu2 equals to delta 0. Test statistic, ito po yung gagamitin natin na formula. Example, a product developer is interested in reducing the drying time of a primer paint. Two formulations of the paint are tested. Formulation 1 is the standard chemistry and formulation 2 is a new drying ingredient that should reduce the drying time. From experience, it is known that the standard deviation of drying time is 8 minutes, and this inherent variability should be unaffected by the addition of the new ingredients. 10 specimens are painted with formulation 1 and another 10 specimens are painted with formulation 2. The 20 specimens are painted in random order. The two average drying times are min 1 equals to 121 minutes and min 2 equals to 112 minutes. Respectively, what conclusion can the product developer draw about the effectiveness of the new ingredients using x equals 0.05? The 8-step procedure is number 1, parameter of interest. The difference in mean drying times nu1 less nu2 and delta 0 equals to 0. Number 2, null hypothesis is nu1 less nu2 equals to 0. Number 3, alternative hypothesis nu1 greater than nu2. Number 4, x equals to 0.05. Number 5, test statistic. The test statistic, ito po yung yung kikita naman dyan sa screen. Ito po yung gagamitin natin na formula. Number 6, reject. If reject, nu1 equals to nu2 if the p-value is less than 0.05. Number 7, if kapag nag-compute tayo ay since equals to 121 121 121 minutes, and mean 2 is equals to 112 minutes. The test statistic is the square root of quantity of 8 over 10 less is equals to is equal to 2.52. Number 8. The conclusion, since equals 2.52, the p-value is p1 equals to 2.52 equals to 0.059. So we reject h at the x equals to 0.05 level. Interpretation. We can conclude that adding the new ingredient to the paint significantly reduces the drying time. Chapter 10. Simple linear regression and correlation. First, empirical method example 1. Do algorithm animation assist learning and empirical study and analysis. Algorithm animation are dynamic graphical illustration of computer algorithms, and they are used as teaching aids to help explain how the algorithm works. Although many people believe that algorithm animation are useful this way, no empirical evidence has ever been presented supporting this belief. We have conducted an empirical study of a priority queue algorithm animation, and the study results indicate that the animation only slightly assisted student understanding. In this article, we analyze those results and hypothesize why algorithm animation may not be as helpful as was initially hoped. We also developed guidelines for making algorithm animation for more useful in the future. A. Empirical models. An empirical model, sometimes called as a statistical model, relies on observation rather than theory. The idea is that if you observe some particular outcome following some particular circumstance, then you can reliably predict that outcome in the future. And the last is letter B. Regression modeling linear relationship, the least squares approach. If the data shows us a linear relationship between two variables, the line that best fit this linear relationship is known as a least square regression line, which minimizes the vertical distance from the data points to the regression. Chapter 8. Test of hypothesis. Letter A. Hypothesis test. Statistical method that use sample data to evaluate a hypothesis about a population. In a statistical hypothesis test, a null hypothesis and an alternative hypothesis is proposed for the probability distribution of the data. If the sample obtained has a probability of occurrence less than the pre-specified threshold probability, the significance level given the null hypothesis is true. The difference between the sample and the null hypothesis is deemed statistically significant. The hypothesis test may then lead to the rejection of null hypothesis and acceptance of alternate hypothesis. Hypothesis testing. The theory, methods, and practice of testing a hypothesis by comparing it with the null hypothesis. The null hypothesis is only rejected if its probability falls below a predetermined significance level, in which case the hypothesis being tested is said to have that level of significance. The logic. State a hypothesis about population, usually concerning a population parameter. Predict characteristics of sample. Obtain a random sample from the population. Compare obtained data to prediction to see if they are consistent. Steps in hypothesis. Step 1. State the hypothesis. Step 2. Set the criteria for a decision. Step 3. Compute the test statistic. Step 4. Make a decision. Letter B. Test on the mean of a normal distribution variance known. A z-test is a statistical test used to determine whether two population means are different when the variance are known and the sample size is large. The test statistic is assumed to have a normal distribution and nuisance parameters such as standard deviation should be known in order for an accurate z-test to be performed. Key takeaways. A z-test is a statistical test to determine whether two population means are different when the variances are known and the sample size is large. A z-test is a hypothesis test in which the z-statistic follows normal distribution. A z-statistic or z-score is a number representing the result from the z-test. Z-tests are closely related to t-tests, but t-tests are best performed when an experiment has a small sample size. Z-tests assume the standard deviation is known, while t-tests assume it is unknown. Understanding the z-test. The z-test is also a hypothesis test in which the z-statistic follows a normal distribution. The z-test is best used for greater than 30 samples because, under the central limit theorem, as the number of samples gets larger, the samples are considered to be approximately normally distributed. When conducting a z-test, The null and alternative hypothesis alpha and z-score should be stated. Next, the test statistic should be calculated and the result and conclusion state. A z-statistic or z-score is a number representing how many standard deviation above or below the mean population, a score derived from a z-test. Example. Assume an investor wishes to test whether the average daily return of a stock is greater than 3%. A simple random sample of 50 returns is calculated and has an average of 2%. Assume the standard deviation of the returns is 2.5%. Therefore, the null hypothesis is when the average of mean is equal to 3%. Conversely, the alternative hypothesis is whether the mean return is greater or less than 3%. Assume an alpha of 0.05% is selected with a two-tailed test. Consequently, there is 0.025% of the sample in each tail and the alpha has a critical value of 1.96 or negative 1.96. If the value of z is greater than 1.96 or less than negative 1.96, the null hypothesis is rejected. The value of z is calculated by subtracting the value of the average daily return selected for the test of 1%, in this case, from the observed average of the samples. Next, divide the resulting value by the standard deviation divided by the square root of the number of observed values. Therefore, the test statistic is 0.02 negative 0.02 minus 0.01 divided by 0.025 divided by 50 equals to 2.83. The investor rejects the null hypothesis since z is greater than 1.96 and concludes that the average daily return is greater than 1%. C. Test on the mean of a normal distribution variance unknown. T-test hypothesis testing for mean with unknown variance in the situation where you have a sample and would like to know if the population represented by the sample has a mean different than some specification, then this is the test for you. In this case, you do not know the actual variance of the population, you just have a sample. This test is often the second one in a textbook that describes hypothesis testing. It is a useful hypothesis test and applies in many situations as we rarely know the population variance. Assumption. A good practice when applying any statistical application is to consider the related assumption. For this test, there are two assumptions involved. Number one, the sample is randomly selected from the population under investigation. Number two, the population distribution is a normal distribution. Note as the sample size goes up, this becomes less of a concern due to the central limit theorem. Generally, when n greater than 25, the difference between the z and t-test is very small. If either assumption is not true, the result of the t-test statistic may not be informative. Example: students' t-tests can be used in real life to compare average. For example, a drug company may want to test a new cancer drug to find out if it's improved life expectancy. In an experiment, there's always a control group, a group who are given a placebo or sugar pill. The control group may show an average life expectancy of +5 years, while the group taking the new drug might have a life expectancy of +6 years. It would seem that the drug might work, but it could be due to a fluke to test. This researcher would use a student's t-test to find out if the results are repeatable for an entire population.